Hey guys, Mr. Gran with a 11.1 challenge video. Now this isn't so much a challenge video as it's just a more of an in-depth explanation of why the formulas that we're using in 11.1 are the way they are. So the difference between the permutation and combination formulas and kind of why they are different in the first place. Okay, so in this situation, we had a cat problem in the lesson, and I just wanted to, so it's kind of the same problem, except we're going to only use 6 cats just so that the numbers are a little bit nicer for this. All right, so we want to know how many ways could we choose first, second, and third favorite of these 6 cats. So really ranking. Now this is going to be a permutation problem because order matters, because if I choose the purple cat is first, the green cat is second, and the black cat is third, that is going to be different than if I pick the black cat as first, the purple cat as second, and the green cat as third. So that is our definition of a permutation. Okay, so when it comes to this, one way to think about it is how many choices do I have for first place? Well, I right now have 6 choices. So we can start out with 6. And I'll choose the purple cat as number 1. Then how many choices do I now have for second place? Well, I have 5 choices. So 6 times 5. Maybe I'll stick with the green cat for second place. Then how many choices do I have left now for third place? And the answer is 4. I have 4 choices. So we'll choose the black cat for third. That's going to give me the total number of ways that I could choose first, second, and third favorite from these cats. Now, if we look at this for the NPR formula, NPR is going to be equal to n factorial over n minus r in parentheses factorial. So in this case, it would be 6p4, which would be 6 factorial over 6, that should be 3, minus 3 factorial. So 6p3, because we're choosing 3, and order matters. All right, so that would simplify to 6 factorial over 6 minus 3 is 3, so 3 factorial. Now if I expand this, 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. And when we divide it by 3 factorial is 3 times 2 times 1. And so you can see the 3, 2, and 1 cancel each other out, and I'm just left with the 6 times 5 times 4, which I used up here originally when I did this problem with more of a sort of like intuitive way rather than trying to use a formula, just sort of thinking my way through it. Okay, so that kind of explains all the factorial stuff with NPR, right? Why you have to have this bottom part to cancel out the extra stuff, right? We didn't choose a 4th place, a 5th place, or a 6th place. We only chose those first 3 places. So that's why we only needed 3 numbers here, and we needed to cancel out the rest of them from the expanded factorial. Okay, so now let's change this problem. How many ways could we just choose 6 cats, right? So now order doesn't matter, so this is a combination problem. Now, again, I can start this sort of as a permutation problem, right? I have 6 choices for the first cat that I pick out of the litter. I have 5 choices for the second cat. I've got 4 choices for the third cat, but it really doesn't matter in which order that I choose them. So let's say that I start out, I chose the purple, the green, and the black cat third, right? That's one total way that I could have done this. Well, I could also have chose it purple first, black second, and green third. So now I've got 2 total ways that I could have chose it, right? And so I need to divide the total at least by 2, because there's really 2 different choices that I could make that would give me the same group of 3 cats. All right, but there's actually more, right? Because maybe I chose the green cat first, and then the purple, and then the black. So that's now 3 total choices, 3 different ways that I could have done it. And maybe I still did the green cat first and then the black and the purple last. So now I'm up to 4 different choices. And maybe instead of doing that, I chose the black cat first, and then the purple, and then the green. So now we're up to 5 different ways we could have chose. And I think the last way I could do this is choosing the black cat first, the green, and then the purple. And that will give me a total of 6 ways that I could have done this. Okay, so now the reason for that is it's actually another permutation problem. It's almost like another permutation problem in here where I know that I'm choosing the purple, the green, and the black cat, but it doesn't matter which order I choose them in, so how many different ways could I choose them? Well, I've got 3 choices for the first cat, and then I've got 2 choices for the second cat, and then 1 choice left for the last cat. And so we end up getting the 6 different ways that we could have chose the cats by doing 3 times 2 times 1. All right, so how does this relate to the NCR formula? Now, NCR is equal to n factorial over r factorial. I'm going to make that red because I'm going to end up with some of the same numbers, times n minus r factorial, right? That's the only difference, is this little r factorial right here. And so now if I apply this to this problem, we're doing 6 choose 3. It is going to be 6 factorial over 3 factorial in red and 6 minus 3 factorial, right? So now if I simplify that a little bit, that's 6 factorial over a red 3 factorial. Now it doesn't need to be red. I just want to distinguish between the extra 3 factorial and the original 3 factorial because these 2 things are actually unrelated. It just happens to be that 3 is used in this problem more than once. All right, so now if I expand this, it is going to be similar to the last one where we've got 6 times 5 times 4 times 3 times 2 times 1 for the 6 factorial. And then my 3 factorials, I've got 3 times 2 times 1 for the red one. And I've got 3 times 2 times 1 for the purple one, the original one. That's going to cancel those out. And what I'm left with is the same thing that I came up with up here when I sort of worked it out without the equation. It came out the same down here. So that's where all the factorials and stuff come from in the 2 formulas, and that's the reason that combinations you end up with less when order doesn't matter, less total ways that you could choose something where order doesn't matter versus when order does matter.